Joins. So one of the SQL most powerful feature is the capability to join tables on the fly with data retrieval queries. Joins are one of the most important operations that you can perform using SQL select statement. And a good understanding of joins and join syntax is an extremely important part of learning SQL. So please pay more attention, especially in the joins. There are multiple types of joins: cross join, inner join, outer join, so and so. So first we will start with cross join. So cross join we also called as Cartesian product. Let's see why this is called Cartesian product and how this join works. So the basic question, why we use joins? If the data is stored in multiple tables, you can retrieve the data with a single select statement by using join condition in select statement. So we have student table and each student is registered with course, but the course details are not in these tables. Course details are in separate table called course. So in that table we have course ID, name, price, instructor. Like that, most of the times data will be divided into multiple tables to save disk space. So that is okay, but when data is divided into multiple tables, so we can create a record, we can prepare a result with join condition on both tables like student and course. So if I join course C1 with course ID, then I'll get the course name, course price, and who is the instructor of that course. So let's start with the Cartesian join and we'll move on to the other joins. So the basic select statement what we know is select star from student. So if I run this, I have 9 records. Like that, if I run select star from course, I have 7 records. So when I put student and course both in the from class, then I got 9 multiplied by 7. So sorry, the student table is having 9 and course table is having 7, and 7 into 9 is 63. So it's a Cartesian product of both tables. That's why it is called Cartesian product. So each record of student will join with each record of course. If you see the result, so the student ID 1 is joined with all courses, 7 courses, and then again another student John is registered with 2 different courses, C1 and C5. That's why it is joined again with all 7 courses. Then student 2, student 3, like that. Each record of student table is joined with course table, and you will see the all columns of both tables. So here we didn't mention anything, just we mentioned comma, but the actual syntax is cross join. So the result is same, 7 into 9, 63 records. And not only that, you can add where condition, group by, everything. Where, so let's see result, where price is greater than 300. So we have only 300 greater than 300 records, 27. So like that, you can add group by, order by, limit, all those conditions what we see in our earlier sessions. And this is not just limited to 2 tables. So let me undo what I mentioned. So we can add more than 2 tables. So we have student, course, and one more table, instructor. So it's 9 multiplied by 7 multiplied by 5. We have 315 records. So if I add one more table, the location table what we used earlier, so the result is limited to 1000 rows because my current setting is for 1000 rows, but the total count will be more than 1000. So let's see how to increase that. Windows, preferences, and just search with result, and here the result I mentioned maximum of 1000. I will increase it to 10,000, and I'll run this query once again. So query is executed and it fetched 8190 records. 8190. So like that you can add as many tables as you want in the join conditions. So let's remove this part. So we added 1 table, 2 tables, 3 tables, like that, right? So you can add even with same table 2 times. I can add student once again. So 9 into 9, 81. So this is called self join. So I am self join and cross join. So I am joining student table with student table itself. And in the result I got, okay, let me add another table. Okay, so for example, if I want course only C5, then if I add where condition, where course is equal to C5, I'll get an error because the error is column ambiguously defined. So this ambiguous condition will arise when you are joining 2 tables which are having same type of column names. So ID name course, ID name course. So I have a course column 2 times. So the DBMS will get confused which course you are trying to restrict. Is the course on left table or right table? For example, so I ran student and course table, and student table is having ID, name, course ID, name, course, and the course is having ID, name, price, instructor. So we have ID, name 2 times, right? If I restrict ID C5, so I know C5 is a course ID. See here, in the course table the ID is a course ID. In a student table ID is a student ID. If I run this, I will get error again because the column name is same. So for this issue there is an option called table aliasing. As of now we see column aliasing, right? So we can change the column names. Similarly we can change table names as well. So for example, if I put student table name as S and course name as C, then in the where condition, if I mention course dot ID is equal to C5, then it will execute. So now I got only C5 course IDs on the course table, and left table will be joined with each record. So I have 9 records in my student table and 9 records are joined with 1 column from the course. So that's how the table aliasing will work. For example, if I mention ID from student table, if I mention full table name student.id, it will give error, because when you done aliasing for any table, so here I did for student table as S, so you should always use alias name of the table, then it will work. So make sure if you are using alias, then aliasing should follow, otherwise use full table name. So here if I remove aliasing, the ID from course table, course.id C5, then we got the same result. So either use table name for the where condition or in the projection list, or so it sometimes when you write a big statement, it's difficult to use the table name again and again. So that's why the table aliasing will come in handy. So most of the cases I see many programmers who does SQL, who wrote SQL, they use table aliasing with short ID C, S, M, something like that. Student S, course C. So they use single letters, so it's easy for them to prepare big statements. So this is called a qualified column name. So table dot and then column name. So this is called qualified column name. So in cross join you can add as many tables as you want, and the result will be Cartesian product of those table records. And mainly when you are using joins, try to use table aliasing to make it simple, and always use qualified column names in projection list or where condition to filter data. Okay, in the next session we'll see inner join, which is more important join we use every day. Thank you. See you in the next session. Until then, happy learning.